Alright, in this circuit we're looking for three things: current through resistor B, power dissipated by resistor D, and voltage drop across resistor C. Now, first thing you want to do is you need to work out your resistance total. So what you need to do is sum these together because these are in series, and then do a parallel calculation of two resistors, these two. So RT equals 40 plus 50 ohms equals 90 ohms. Then we need to do the parallel resistance calculation, which is this. So what I recommend, if you don't know how to do this, you can just get an easy calculator like this. This is an FX100. It's available at Officeworks for about $40. You hit this button here. It gives you this. So I can do 1 on the top, and then I can do that button again, and it puts 1 in there. 100 plus, hit that button again, 1 over 90. Hit this S to D because it changes from a fraction to a decimal. 47.36. So that's the resistance of that part of the circuit. Now resistance in series just sums. So I can take my 47 and I can plus my 500, and that's going to equal 547.37 ohms. So that's my resistance total. Now what you're going to want to do is we need to find the current total. So what I can do is, again, you can just use these triangles. If you don't know the formulas, then you can't transpose. So I'm looking for the current. So it's V over R. So IT equals 200 volts over 547.37 ohms. So it's 200 over 547.37 equals 0.365 amps. Alright, now I can label this in here 0.365 amps to give me the idea of what's going on. I need to now find the current through B. Well, I know there's 200 volts here. I don't have any of the voltage drop across here yet, but the easiest way to do it now is I can work out what the voltage drop across this resistor is and take it from the 200, and that'll give me the voltage drop across here, and then I can work out the current through this resistor. So to work out VD, so I look for VD is IR, so it's 0.365 by 500 equals 182.7 volts, because I rounded. Alright, so I can then go VB, because remember the voltage across these 2 points is the same as here and here. VB equals 200 volts minus 182.7 volts. So So what I can do is go 200 minus 182.7 volts equals 17.3 volts. Now look, there is easier ways and different ways of doing it, but that gives you the shortest amount of work to work it out. Alright, so now what we can do is we're going to look for this first part, the current through resistor B. So again, I equals V over R, so we can look for IB equals 17.3 volts over 100 ohms. So divide that by 100 ohms equals 0.173 amps. So that's the answer to that first bit. So I'll just change my pen. Equals 0.173 amps. Alright, power dissipated by D, that's an easy one. So if we want PD now. Alright, P again, you can look for it, use this triangle if you need to, or it's P equals VI or P equals IV. So you go P equals I times V. So I know the current is 0.365 amps multiplied by 182.7. $66.68 watts. So the answer to this one is 66.68 watts. Now we're just looking for the voltage drop across C. So what we need to do here, alright, I'll switch the pen back to the blue one. So remember what current goes into here goes this way and this way, and the same goes here. This is made up of the current flowing in this way and this way. So I know that current and I know this current. So this current was 0.173 amps. So what I can do is I can take the current total and minus current B. So what I'm going to be going for is IC, because remember these are in series, so the current that flows through this one is the current that flows through this one. IC equals IT minus IB equals 0.365 amps minus 0.173 amps equals. So I'll just quickly type that in. .192 amps. So I can write that up here to make it a bit easier to see. Alright, now we've got everything to find the voltage. So remember, V equals IR, so VD equals 0.192 multiplied by 50 ohms amps equals 9.6 volts. So the answer to this one, 9.6 volts. And that's it. That's how you solve it.